everyone, I am STELLA MONTAJES and welcome to our channel. In this video, our lesson is about theorems and limits in basic calculus, but we'll focus on Theorem 1 and Theorem 2. This two is the most basic and simplest but powerful tools when dealing with limits. To help you understand better, we'll include some examples and even real-life applications. So let's start. So let's proceed with the theorem 1, which is the limit of a constant. It says that if c is a constant, then limit of c as x approaches to a is equals to c. That means if a function is just a constant value, then the limit of that function as x approaches any numbers is simply the constant itself. To illustrate, limit of 5 as x approaches to 2 is 5 because 5 is a constant. In theorem 1, this given. For real life application of theorem 1, think of your refrigerator. If you set it to 5 degrees Celsius, even as time changes, the temperature stays at 5 degrees Celsius, and that's like a constant function. Next is Theorem 2, which is the limit of the identity function. It says that if f of x is equal to x, then limit of x as x approaches to a is equal to a. This is called the identity function. It means if the function is just x, then the limit as x approaches a is just a. Illustrate theorem 2, so let's start with this problem. Limit of x as x approaches to 5 is equal to, so according to theorem 2, if the function is just x, then the limit as x approaches to a is just a. So here, this is the x. So what number is approaching x? So mao daw nato ang answer. So 5. So 5 atong answer diri a. Kumbaga kung sa theorem 1, kung unsay naa diri a mao ang answer. While sa theorem 2, kung unsay number nga gi-approach niya mao ang atong limit. So let's have another example. Limit of x as x approaches to 12. So our answer here is 12 because this is the limit or the identity. So let's have some example more. Limit of x as x approaches to 1/2. So our answer here is 1/2. For real-life application of Theorem 2, imagine you're tracking time in minutes. At exactly 10 minutes, your stopwatch reads 10. The value of the function is just equal to the input. So, if time is approaching 10, the value also approaches 10. So, this is a real-life version of limit of x as x approaches to 10 is equal to 10. So let's have quick review. Theorem 1 is the limit of a constant is just that constant, while the Theorem 2 is the limit of x as x approaches a is just a. These seem simple, but they build the foundation for more complex limit proofs, like the sum, difference, product, and quotient theorems.